How's it going? This is Mike coming at you with another video on number theory. In the previous video, we saw several sample problems as to how do we use the Chinese remainder theorem to solve a system of three linear congruences in one variable. In this video, this is all going to be on chapter 5. There's just two really quick theorems I want to mention in this video. It's going to be a very, very short video. And these theorems all pertain to how can you use these results to find what a large number is congruent to mod some number n. So as you can see, these two results can aid in solving linear congruences or any congruence mod n. The first result and its corollary being much more useful than the second one. The second one, which as we'll see is called Wilson's theorem, it hardly ever gets used in this course, but I figured I'd throw it in there just for the heck of it. And these theorems can only be used when your n value, when you're taking something mod n, when your n value is a prime, then you can use either of these facts to make your life a bit easier. So the big one that is really going to serve you more in any potential problem you'll see is Fermat's theorem, which says let P be a prime and suppose that P does not divide A. Then A raised to the power P minus 1 is congruent to 1 mod P. So check that what you're taking things mod is a prime. If it is, and then as long as your A value here is not a multiple of that prime P, then take A, raise it to the power P minus 1, and you automatically know that that is congruent to 1 mod P. The corollary to this theorem removes the condition that P does not divide A. That doesn't have to be the case here. The corollary says that if P is just a prime, then A to the P is congruent to A mod P. So that's a nice little thing. If you're not sure about the whole divisibility condition, then work with this guy here. If you know for a fact and you're comfortable with the condition on non-divisibility, then use this guy right here. And here I just have a couple samples that show you how this theorem and its corollary get used. So I'll let you check those guys out on your own. Pretty straightforward to see what's going on there. And then the other theorem that I wanted to mention, which is called Wilson's theorem, it says that if P is prime, then P minus 1 factorial is congruent to negative 1 mod P, which is in turn congruent to P minus 1 mod P. As I said, this result not used nearly as much. In fact, you won't have to use it for any problem in my class, but if you'd like to learn more about number theory on your own, you may find the use of this theorem to be quite helpful. So these are the only two facts that I wanted to mention in terms of chapter 5, just these two quick theorems. Fermat's theorem and the corollary are the ones that could potentially help you on a homework or quiz or test question. In the next video, we'll get into chapter 6 when we begin to talk about number theoretic functions and the number of positive divisors and the sum of those positive divisors of any given number n. If you have any questions or comments, be sure to drop them in the comments section below. Otherwise, until the next video, take it easy, guys.